Okay, I hope everybody's doing well. This is section 7.4, matrices and systems. So we're finally going to learn what these matrices are all about. A matrix is technically a rectangular array of real numbers, but it's just a way to organize data. Computers use matrices a lot so that we can organize our data. So I want you to read the definition in the box. If m and m are positive integers, then m by n, so that's how you read it, right? Just like a 2 by 4, it's 2x4, m by n. Matrix is a rectangular array given there with a bunch of variables in which each entry of the matrix is a real number, and m by n matrix has m rows and n columns. So rows and columns, we got to make sure we get that right. So rows go sideways. I don't even know if you guys can see that highlight. Rows go sideways, you can kind of see that a little better. And columns go vertically. So it's R by C is how I shorten it, right? Number of rows by number of columns. So dimensions might also be called the order of your matrix, depending on the book or publisher or whatever you're looking at. Looking at these two matrices, see if you can find the dimensions of those two matrices. So row, how many rows are there? By, how many columns are there? Pause your video and see if you get the same thing as me. Okay, hopefully you got that number 1 is a 2 by 3 and number 2 is a 3 by 1. That's going to be really important later on, but as we're talking about matrices, now you know what the dimensions represent. Okay, so how are they helpful? Augmented matrix, a matrix derived from a system of linear equations. So, that's how we started the chapter off, right, with systems. So we're going to take our system and we're just going to put the coefficients into the matrix. So equation number 1 goes on the top row, equation 2 goes in the middle row, and equation 3 goes in the bottom row. If there's any gaps, make sure you include a 0. Your matrix needs to be full of real numbers. So write number 1 off to the side right there. See if you can turn that into a matrix. I know it looks like there's only 2 variables because there's only 2 terms in each equation, but notice it's x, y, z, so it will be a full matrix. You can pause the video if you'd like and see if you can get it right. I'm going to walk through it. So I usually just kind of set my matrices up extra big and leave them open to see how much room I need. X, Y, Z, right, in alphabetical order. 1x, leave a little space. 3 y's, leave a space. 0 z's. And it is common practice to put a dotted line here. Honestly, I just find it easier, especially on the iPad, to put a solid line there. And then 9. If you were using a calculator or something, that line wouldn't even be there. So don't worry about that line. It's just helping us visualize that on the other side is where the constants go. See if you can do the other 2 rows now that I've done row 1. Match them up. Pause the video. Okay, check and see if you got the same augmented matrix as me. So I took the system of equations and I put it into an augmented matrix. We'll see in a minute why that makes it easier. First of all, you should notice there's no more variables that we have to write down every single time, so that makes it a little easier. So we are going to do our Gaussian elimination that we went over last class, video, whatever you want to call it, and we are going to apply it to a matrix instead. So take equation 2 and put it into its augmented matrix, just like we did in equation 1. Pause it and see if you can get the right matrix. Okay, check and see if you got the same matrix as me. And then we are going to apply that same rule. We want that stair-step pattern, right? We already have the first term in the first row is a single positive 1. Technically there's an x there, but we don't have to write it down anymore, right? So we've got that first part. Now we want to work on right below it. Do you remember what that coefficient is supposed to be? That yellow coefficient is supposed to be a 0. So what row operations can we do, just like we did before, but now we're doing it in a matrix? What row operations can we do to make that turn into a 0? See if you can try it on your own. I'm going to set it up. Okay, here we go. I'm just setting it up. I copied row 1 down as is. I'm not going to change that. Okay, so what can we do to make row 2 start with a 0? Hopefully what you decided to do, although I need you to know there's a bunch of different ways you can make this happen. There's not like a set rule for the steps you take, but please make sure you show your steps. the first thing I'm going to do is I'm going to take row 2 and I'm going to add it to row 1. Because then clearly I'm going to get 0 here. Row 2 plus row 1. Row 2 plus row 1. Row 2 plus row 1. So now we're good for our stair step. We've got the 1 here. This is a 0. Do you remember what we do next? We want the next x coefficient to become 0. Figure out what row operations you can do to make that next yellow number 2 become a 0. Pause your video. Okay, so again, I set it up. I'm good with row 1. I'm good with row 2. To make row 3 zero out that first term, that 2, to go from here to here, I need to use row 1 because it's the only one that has a number. So I'm going to do row 3 minus 2 row 1. If you haven't yet, pause your video and do that math to get your new row 3. Okay, hopefully you got what I got. Remember, matrices, lots of places to make a tiny mistake. So stair step starts with the 1, 0, 0. Now we need to work on this. We need to 0 that out. Remember, for your stair steps, these 3 need to end up being 0. Pause the video and see if you can make that happen. Hint, you want to make sure you use row 2, because if I use row 1, I'm going to end up changing that 0 right there, and that's not what I want to do. Okay, so row 2 plus row 3, or row 3 plus row 2, however you want to write it or say it, ends up giving me that 0 I need. Now I have the stair step that I needed. So now we're going to take it on a matrix form and put it back into x's and y's and z's, but it's just like the one we did last time. This bottom row really says 3z, because it's in the third column, equals, that's why I put that bar or that dotted line there, 6. Well, that's super easy to solve for z. So solve for z. Oops, I wrote z. What do you do once you have z? You plug it back into the next row or equation. Remember, that equation says 1y plus 4, instead of z though, I know it's 2, equals 7. Solve that equation for y. Once you have 2 variables, plug it all the way back up into the first equation, which reads x minus 2 times y plus 3 times z equals 9. Solve that. I'm running out of space. And make sure you write your solution as a point. You are finding the point where they cross. If you finish solving that last equation and you write it x comma y comma z, you should get 1 comma negative 1 comma 2. So same thing we did before, but I had to write a lot less because I wasn't writing the variables every single time, and it keeps it a little more organized. Okay, looking at the next page of your notes, I do know that this is the next problem. That's why I have it here for you. It's talking about reduced row echelon form. Notice it still has that stair step that we keep talking about, maybe including that 1 in our stair step idea. But then it makes the other corner be zeros also. This is helpful because if you look at this augmented matrix, the top line just says x equals a, right? 1x plus 0y plus 0z equals a. The second line just says y equals b, and the third line just says z equals c. I should be saying row, not line, which tells me the answers are a comma b comma c. So you can see how reduced row echelon form is super helpful. However, in this course, we really only do reduced row echelon form on a graphing calculator. So I'm going to come back to this slide and show you how. But for now, I want to go on to number 2. The reason I want to go on to number 2 is because I already know the answers to number 1 come out to be crazy fractions. I'm not going to have that happen on test day. So let's do one that comes out a little nicer. Here's problem number 2 on the same page. Go ahead and set up, this picture is really big, set up the reduced row, the augmented matrix for this system of equations. Pause your video. Okay, I fixed my slide a little bit. So hopefully this is the augmented matrix you got. Remember, lots of places to forget a negative or make a tiny mistake, so be super careful. We're lucky, we already have the 1 in the top corner. So work on making the next row start with a 0. Again, more than one way to do that. There's, in my opinion, an easy way to do it in this case, but every single time we do these, there's always more than one way to do it. See if you can come up with the next matrix. Okay, so I took row 2 and I subtracted 2 row 1. This is my new matrix. Next step, we need that -3 at the bottom to become a 1. Only one way to make that happen. So see if you find the same step that I do and get the same matrix I do. Pause your video. Okay, so taking row 3 and adding 3 row 1s gives us that next 0 that we were looking for. Finally, the -4. Maybe we can work on making that a 0. But I do want to show you some other options. Again, infinite number of ways to get these matrices in the right form. If you look at row 2, 5, -5, -10, I can make that simpler. Remember, one of the things we've been doing is multiplying matrices by numbers. So if you think of it as division, that's fine. If I divide that whole row by 5, I am allowed to do that, just like I'm allowed to multiply that whole row by 5. When you're dividing, though, you write it as 1/5. So if I take 1/5 row 2 right now, and I write my new matrix down, I think it'll make the next step a little easier, but there were other ways you could have done it. You did not have to do that, but that's what I'm going to do to show you another way. Pause your video. Do 1/5 R2. Okay, so by doing that, I get that row down to be 0, 1, -1, -2, which is smaller numbers, which oftentimes makes things easier. Now, if I'm still trying to make my stair step 0, it looks to me like using row 2 and row 3 might be a little easier. Again, you didn't have to do that. You could have used row 2 and row 1. I just want to show you different things you're allowed to do with matrices. So go ahead and 0 out that yellow -4. Pause your video. Okay, so nope, I wrote it down wrong. Hopefully you got 0, 0, 3, 3 for the bottom row. I did not change my first or second row in that step. One step at a time. When you guys move on to AP Calculus and you're taking AP tests and stuff like that, they need to see all your work and you need to show it neatly and organized. Next year's teacher is not going to take the time to look at what you were doing and try to figure out what math you did. But right now, if I needed to look at, I don't know, this blue step, I could easily see what math you did and I could help you find your mistake. Okay, so based on what we have now, because we've got that 0 stair step in there, we have everything we need to be able to solve for z, and then solve for y, and then solve for x. I would pause your video and see if you can solve for all 3. See if you can finish this problem. Okay, hopefully you got the point to -1, 1. Just a heads up, if you ever want to know if you got this right or not, right? You did all that work and you want to make sure you got it right. You go back and you plug in the point to -1, 1 into the equations. So 2 minus 2 times -1 plus 3 times 1 should equal 7. If it does, you're good, but you need to check the next equation. 2 times 2 plus -1 plus 1 has to equal 4. And finally, check the bottom equation. Make sure the solution you got works for every equation in the system. And if it does, then you know you got it right. Also, if it's ever multiple choice, maybe it's quicker to check the 4 answers in all 3 equations to make sure they work. But now you know how to solve them, which is also going to be important in life because not every test in life is multiple choice. Okay, back to the one right before this. In our calculator, how do we use the calculator to solve matrices? As long as you're not asked to show your work, this is life-changing, I really feel. Teachers, when we give system problems, we use matrices all the time to solve the system super quickly when a student has a question on it. So you need a graphing calculator. If you don't have one, that's fine because you are not required to have one on this test, but I want to teach you how to do it. So let's turn number 1 into a augmented matrix. Go ahead and do that. Pause your video. Okay, as long as I didn't make any mistakes, here's my augmented matrix. I didn't put that line, I'll put it in super light gray, but I didn't put it because it's not in the calculator and I don't want you to get confused in the calculator. Now find the order of this matrix. Remember, order is the dimensions. What are the dimensions? And I'm going to erase that line again because I don't want you to be confused. What are the dimensions of this entire matrix? Hopefully you got the dimensions were 3 by 4. So on your calculator, right above the button that says x to the negative 1, right above that, it says matrix. It is on the left side, kind of close to the sign, right next to the sign button. So you want to press second matrix. So you'd press second first to get into your matrices menu. Then it's going to give you the names. When it gives you the names, they're just listed A, B, C, D, etc. You don't have anything typed in there yet, so the names aren't helpful right now. You want to scroll to the right twice to where it says edit. Edit with a T. And then press enter. We're just pressing enter on matrix A. If I had lots of matrices in there, maybe I'd go down to B, C, D, etc. But I'm just going to edit matrix A. So at the top, it says matrix. They even put brackets around it like you're supposed to for a matrix A. And your cursor should be right over the dimensions. So type in the dimensions that we figured out. Our matrix is 3 by 4. So type a 3, press enter. Type a 4, press enter. Then it's going to give you a matrix to fill in. You have your matrix right there in front of you. One thing to know when you're going through these, every time you press enter, it's going to go sideways. So keep that in mind if you're trying to type these in quickly. You will type it in 1, 2, etc. all the way to 4. Then when you press enter, you'll do the next row. And then when you press enter, you'll do the bottom row. Get your matrix typed into your graphing calculator. Once you get it all typed in, it doesn't hurt to scroll back through it and make sure you typed it in correctly. Just like when we were writing them by hand, typing them in, lots of chances to make a tiny mistake. Then we need to quit. So we are going to exit out of this. Second mode is where you will see the quit button. Then, annoyingly enough, we need to go back. So second matrix. I know the button doesn't say matrix, but that's where you want to go. So second matrix. Now we want to do some math to it. So scroll to the right where it says math. We are doing reduced row echelon form. If you look at the top of this paper, reduced row echelon form, or RREF. If you scroll down, it's not one of the top ones, although it's one of the many often used ones. If you scroll down to B, so press down until you see RREF and a parenthesis. When you get there, press enter on your calculator. It's going to bring that to your home screen. And then you need to tell it what you want to take the reduced row echelon form of. We want to take it of matrix A. So we're going to have to go back. Second, matrix. The names tab that it brings you back to every single time, that is where you go to grab the matrix that you want to do math on. So when you go to matrix and it says names A, we want A, right? So make sure it's highlighted and then press enter, and it should put it in your home screen right there in a bracket to represent a matrix. You don't technically have to close the parentheses. You can just press enter and it will give you the reduced row echelon form. Remember in the corner over here, the whole point is that these numbers are the answers. So if your calculator gets your reduced row echelon form, you might want to turn it into a fraction. So math fraction. Which is really just math, enter, enter. That's the enter button on a keyboard, right? Math, enter, enter. It'll turn it into fractions for you. And then they're in order. -5/3, comma, 7/3, comma, -1. If these aren't the answers you got, you made a mistake when you typed it in. So go back and double check your matrix. So now you know how to solve them in a calculator, which means now you know how to check all of your work. So, last page for today. This page is for you to practice doing it by hand. We've already learned what's on this page. I want you to practice doing your Gaussian elimination by hand. So, take your take your system and put it into an augmented matrix. And then do all the steps. Work on getting your stair step zeroed out in the correct order to make it easier. And check and see if you got it right. Good news is now you can type it into a calculator and see if you got it right or not. But also if you pause the video and practice by hand, and next time you unpause the video, I will write the answer down to make sure you know if you got it right or not. Okay, so if you do this one by hand for practice, you should get 1, -1, 2. Okay, that's it for today. I hope you guys are doing good.